head of developer relationship, is going to show us a very interesting new business model. Thank you, Michael.
Thank you. Thanks for inviting me to this conference. I'm very pleased to be here and pleased to be able to talk about Openmoko. How do we start? There we are. So a little bit of background about Openmoko, and then rather than talk in great detail about what we are and how we work, I'm sort of going to slice across it and do a bit of a case study in whether we've succeeded or not. So the Openmoko project is briefly a family of mobile computing devices running Linux and free open source software. It is also a Linux distribution that's primarily targeted at mobile computing devices. And then it also is the name of my company, the company that's within which this project is being done. Now, the reason that this project was created is that the parent company, the company that funded this, wanted to create the mobile computing devices of the future. And what they meant by that was not just another cell phone and not just another iteration of a cell phone, but something a little beyond that. We spoke yesterday about timeframes of 5, 10, 15 years. Those are the kind of things that they were thinking of. Now, the cell phone seemed like a really good place to start, but it seemed to be a stepping stone rather than an end point. The problem is that we have this circular dependency problem. The problem is we can't really design the innovative hardware because we don't know what the applications will need from that hardware. So, for instance, the question is, an example might be, what sort of video support does it need? What sort of network support does it need? Obviously, you'd like to have as many as possible, but we're not quite sure what that will look like in the future. Now, the flip side of that is developers can't develop innovative applications if they don't know that the hardware will be able to provide it. So how does a particular company start a project like this and create the appropriate handset or mobile computing device that will allow innovative applications and then get the community, get the developers to create these applications? So our solution was a little different, and this is where Openmoko turned to the open source community. The idea was that we wanted to build an extremely creative, imaginative, innovative, and flexible development team. We wanted to create a very nimble hardware team, and we wanted to create a tight relationship between the two. The reason for that tight relationship is to get around this circular dependency. So we wanted to reduce the amount of time it would take for feedback to come from the software side of things to tell the hardware team what needed to be done. And the policy that we adopted was the sort of a rapid prototype concept, which was get something out as quickly as possible, start developing with that, see what kind of ideas that suggests, and then listen to the people developing those and think about what we can add to go further. And as I mentioned earlier, the place we thought we would find such a team is the open source community. The reason for that is manifold. One is that they're very creative. They're used to thinking outside of the box. They tend to be non-traditional. They have very varied backgrounds. In fact, many of them don't even work as developers, and especially not in the mobile computing field, as their day job. So they're doing this as a hobby, as an interest, as something outside of their regular line of work, which means that they have a background, they have interests, they have a need perhaps in very, very different fields. They're not always driven by profit or practicality. So, for instance, one aspect that is extremely interesting to me personally are artists. What sort of applications, what sort of ideas would artists come up with? What sort of hardware needs would artists come up with? That somebody thinking in terms of practical things might not. It's a huge community. And then just to be honest, we will admit it's a relatively inexpensive community. We were able to sort of get into this at a lower price than if we had to build such a team ourselves. So here's how we tested this project. And I should say that I'm putting this order of the test sort of retrospectively. I'm not sure if we had planned it as a test when we started the project and sort of said we'll do the following steps. So the project was announced to the world, as I think David pointed out, in March of last year. And there was immediately a tremendous amount of interest, a huge appetite. We built the first handset in this family. And I should say the reason that we built our own hardware is twofold. One is that we are part of a hardware manufacturer, and obviously that's one of the ways that they are going to generate income. The other is that if we wanted to make this platform truly open source all the way down, we needed to choose chips for which we could provide open source drivers. And one of the problems with many existing cell phone handsets is that many of the chips are under sufficient NDAs that we cannot get access to open source drivers for those. So we put out this first handset, what we call the Neo 1973, and we sold it out of our entire stock in 3 days. And I'm told that the only reason it took that long was that our server, the typical Slashdot effect, the server that was handling our sales kept crashing due to it being overloaded. So this tells us that this approach is successful. The other interesting aspect is, how did this look from the software team point of view? And the interesting thing here is, I wish I had some very solid numbers for you, because I think that they're quite impressive, but I don't, so I'm just going to use general terms like thousands. We have a number of mailing lists that support this project. One of them is a community mailing list, which is sort of the main meeting point of people involved in this project. So that would include hardware designers, software designers, people out in the community, people within the company, people who are interested in very specific aspects of the project, very specific applications. So really everybody involved. And there are thousands of people involved on that mailing list. And what's really more impressive than just the sheer numbers is the fact that it's a relatively high volume mailing list. And still those thousands haven't unsubscribed in droves, as might happen when volume gets very high. Indeed, we have a huge variety of backgrounds. The kind of subjects that you'll see being discussed on the mailing list really, I wish I had some examples of the kind of things that are discussed, but it really spans the whole range of very, very technical things like kernel latencies and esoteric issues, all the way to very, very practical applications from a user's point of view, philosophical issues such as security and privacy, and all in the context of what does this mean to the Openmoko project. As I mentioned, we have a mix of hardware and software people, so we're able to discuss things like, I wish I could do this application, but it lacks this type of hardware, and there are people on the mailing list who can say, well, I happen to be a hardware person, and you could satisfy that with such and such a chip, or such and such a chip set. And then people within the company who can say, we don't have room for that, the price is too high, or whatever, and we can have a discussion about how to actually enable that feature. Indeed, we have extremely bright, creative, and imaginative people, and they're very passionate and involved. As I said, this is a large mailing list with quite a high volume, and we see it isn't one that is co-opted by a small handful of people who have private discussions. There's a huge amount of participation. So in conclusion, I would say this method of developing in the open source community, and by having a tight relationship between the developers and the hardware design team, we did solve that circular dependency problem. And I'll bring a couple of examples, and this is sort of the case study aspect of it. As I mentioned, we came out with the first phone last year, the Neo 1973. One of the features lacking from it that people knew about even beforehand was the fact that we didn't have Wi-Fi. Now, we did that intentionally for one reason, is that we thought that the benefit of Wi-Fi would be outweighed by the increased cost. And the community almost immediately told us, no, you have it dead wrong. Wi-Fi is so important that network connectivity that doesn't depend on a cell phone network is so important to us that we will pay quite a high price for that. Now, in reality, we were able to do that without a huge increase in price, but they told us unequivocally that we made a wrong assumption there. Another interesting thing was one oh, and I should mention on Wi-Fi, another aspect of that was that we couldn't find a Wi-Fi chipset for which we could completely open source the drivers. And the community stepped in here and said, we'll find some for you. And they went off and did a bunch of research. There are a lot of people on the community mailing list who work at Wi-Fi chipset manufacturers or involved in things like that. And where it came from exactly, I don't know, but eventually someone was able to find a chipset that allowed us to develop open source drivers and to release the drivers under open source. Second interesting thing, and this is one that came up completely from the community, was accelerometers. So as probably many of you know, accelerometers are devices that measure the gravitational field of the Earth. Well, any kind of acceleration, such as the gravitational field of the Earth. And you see them, for example, in the game controller, the Y game controller. In fact, I think we can thank the Y, or I'm sorry, I mispronounced it. I'm not a game player myself. The Wii, is that correct? I think we can thank the Wii game controller for bringing the price of these devices down because they're manufacturing them in such high volume. So the community came up with the idea that if we had such accelerometers, we could do obvious things such as gesture-based navigation. So if you're holding this thing flat and you tilt it this way, maybe your cursor moves down to the side. If you have maps, provides a very natural way of sort of moving around maps. Since the hardware people were also involved in this discussion, they said, this is wonderful. These chips are very cheap. They're very small, so they don't actually require a lot of work to sort of fit into the device somewhere. And another interesting aspect that a lot of software people might not have thought of is that you don't need to make any changes to the outside plastic of the device. This is something that's completely internal. As many of you might know from a manufacturing point of view, changing the plastic case of a product is incredibly expensive. So when someone comes up with a great idea that opens up the possibility of a lot more applications and doesn't require the plastic to change, that's a big plus. Once we suggested on the mailing list that accelerometers were a very strong possibility, there was this tremendous burst of innovative ideas that came up. So people came up with ideas such as, the device has GPS, it's location aware. If GPS knows that you're driving, in other words, you're moving relatively fast, and suddenly you slam on the brakes, so the accelerometer is able to detect the sudden deceleration, you've probably slammed on the brakes, and your phone rings, or in other words, you get an incoming call. Perhaps rather than ringing your phone at that time, it would be a good idea to just have it go directly to voicemail. Now, obviously, this would be something that would be completely configurable and selected by the user, but the fact that you can now mix certain features like that, I'm using GPS, information from the accelerometer, and using that to control whether the phone will ring or just send the message directly to voicemail. Another application that came up related to the health field, that I know we have some representatives from here, is that if this handset is in the hand of an elderly patient or somebody with any other kind of potential difficulties, if the phone detects that they suddenly have fallen and perhaps don't move for a certain amount of time afterwards, it might automatically call out for emergency help. And since it has GPS and it's location aware. One of the more interesting ones that came up was if I want to exchange my business card, my card information with somebody else, but I want to make sure that I'm going to that person and not to somebody else who might be monitoring the same Bluetooth channel. I want to exchange some kind of a signature that says that this, I am me and you are you. And someone came up with the idea of taking the two phones, holding them next to each other, and shaking them in some arbitrary fashion. And the fact that the two phones were held together and being shaken meant that they would have the same sort of acceleration signatures. It would almost be like exchanging a PGP key or something. And somebody standing next by and trying to mimic the shaking wouldn't get that same kind of signature. So it was just a totally silly idea. I think it came out of the discussion of dancing in a bar or something like that. And yet, could be potentially quite interesting. And had we not had the community involved in this discussion, the idea of accelerometers may not have occurred to us, or may not have occurred to us as quickly. And in fact, when the next phone came out, it did have these two features. And I believe that is the end. Thank you very much.
Thank you. Thank you, Michael. Very interesting presentation. We're moving now to the